Okay, ladies and gentlemen, here's a second example. It's slightly more complex. Okay, it's still the seven problem-solving steps. That's the point, right? We can do every problem that you might have. This strategy is helpful in our physics class this year. So what we have is another example. It's kind of still more. It involves geometry as well as chemistry. So there are more principles involved than just math. And I think that's what I like best about this example is that yeah, it involves a couple of principles and you have to put everything together. But the first two steps, you don't get overwhelmed. You start with what is our target, what are we looking for, and what information do we have, which is step one. And our target is solving for mass in kilograms. What is the mass of the water in kilograms, which is inside of the cylinder that we're talking about? Well, it looks like we should draw a diagram, and the diagram should be probably a cylinder, right? So we're going to draw a picture of our cylinder, and then we're going to think about how much water is in this cylinder. And the only other information we have about the cylinder is the cylinder's height, and it looks like the cylinder's diameter. Okay, so wow, we got these two dimensions from a cylinder. We're going to pour water in, and then from that, we're supposed to figure out what the mass of the water is. So that's going to involve us really using some knowledge and putting that knowledge together in a thoughtful way. Okay? But we're smart, we can do this, right? So, the first thing that you can think about after putting your dimensions in is probably things that involve some geometry, right? We're drawing a picture after all. So, on our diagram, usually when you have a diagram, you list your givens with the diagram, so that's what we're doing here. And also, I think what's important is defining your variables in terms of letters. Okay, so when mass is in kilograms, and what I noticed we didn't say that mass was just going to be the letter M. Here we're saying height is going to be the letter H, and that's how we're going to use the letter H mathematically throughout the rest of our solution. Okay, so height is H, and D is diameter, and mass should be M, which is what we're going to use later, even though we should have really stated that right at the beginning. M equals question mark up there in red. Notice that in red, that's always my target. I like to do that in a different color because that's the target. It's the most important thing, the mass in kilograms of the water in this cylinder. But we have D for diameter, and we have height is H, and we have our not only our number but our units, okay, centimeters, which was in the givens. 28.5 centimeters, 10.4 centimeters, and the mass in kilograms at the end of the day. Looks like I might have fussed around a bit with like how this looks. But what is R? R is radius, guys, right? So even though it might have been better if I stated the word radius, right? We want to be clear about how we explain things. Fortunately, I have a voiceover that kind of bails me out. But sometimes you should write the word with its symbol for those people who aren't familiar. And that would have been the correct thing to do here. It's kind of funny, I do my voiceovers and then I kind of catch the things that I miss when I was doing the screen kind of shot video. But those are our givens. We have our first two steps done. We're looking for mass in kilograms, which we'll use the letter M. And then we have height and diameter. Therefore, we have radius, right? Radius is half the diameter. So I'm kind of skipping steps too, you know. But even as I'm skipping steps, there's a lot of steps that that are there that we have to do with a problem like this. I'm starting to look at step 3. What principles do we need? Well, I know I can figure out volume from these dimensions. I mean, I have height and I have diameter, which means I have radius. It means I'm probably going to use volume at some point. So I'm just taking an initial guess. And volume is the area of the base, right? And multiplied by the height. So that'll be, we can use the letters A and H, area of the base and the height. So A times H is what we're going to use. And the area of the base, well, that's a circle, isn't it? So what's the area of a circle? So that's another equation that we are going to use. So that's a whole, we have many different formulas that we're using. We should list them all because that's a problem solving step. So you can see how this example is starting to get, things are getting a little more complicated, right? There's more to this recipe than there was for that first problem. It's always nice to write things nicely, so I guess what you can see here is I kind of got fussy and maybe obsessive compulsive disorder, and I found the nice little symbol for pi. But yes, the area of a circle is pi r squared. Once we have the area of the circle, which is pi r squared, we have a, and then we'll do a times h, right? And then we'll have the volume. So that's the thing too now. We'll have the volume and then we'll be thinking, oh, we did a bunch of work and we solved for volume. So looks like we solved the problem. So that must mean that the problem is the solution's over, right? But that's not the solution, right? This wasn't just about solving for the volume. You always have to refer back to that step one there, which is what were you solving for? And you can see that at the top. The top is we're solving for the mass of this thing in kilograms. Okay? So even after we solve for the volume here, which is a wonderful thing, okay, we're going to have to find mass. So we have to think about this. So we're not done thinking about what we got to do. We have to solve for mass. So how is volume related to mass? Well, there's another principle, right? We're listing equations and principles. And so we have a principle from chemistry. And chemistry is talking about the density of water. And density in general is mass divided by volume. So what is the density of water? Well, I don't know if we remember, but it should have been 1 gram divided 1 gram. And for every mass, 1 gram of water you have 1 milliliter, right? And 1 milliliter corresponds to centimeters cubed. Okay, so that's what I'm listing there. But you know, it's important once again to list certain things. Where did this come from? This 1 gram per centimeters cubed? Well, that's the same thing as 1 gram per milliliter, which most people might have learned from chemistry, perhaps. So sometimes it seems like I'm OC, but notice, you know, I'm missing steps. As detailed as this is, it might be kind of painful because there's so many details. I actually left a few things out. Like I didn't say that radius was r or that mass was m. Those are actually kind of errors, but yeah, I think a lot of you are like, well, Mr. Freitas, I understand what that means. Like, that's not a big deal. So, but you know, you should do them as many details as possible because you never know who might be judging you. Ultimately, on the AP test, someone is going to look at what you wrote, and if they don't, and if they like to have all the details, you might be in bad shape. Anyway, you know, there's problems within problems. You know, it looks like we're solving for the area first, which is one thing, and then after that, we got to do area times height, which is volume. There's many steps to this, steps within steps. But pi r squared, and I think I noticed that I had a fussy time with my calculator here. I actually prefer using a physical calculator, and I hope that you all do too throughout the course of our course. So a nice physical scientific calculator, Texas Instrument, Casio, Canon. That's essentially what you're supposed to use, and you're not supposed to use any other gadgets for doing physics. I don't know if things work out for all of us. We'll be taking our tests in a classroom that is nice and air conditioned, but we'll see what happens by the end of the year. Okay, so finally, 3.14 times 5.2 squared is 85 centimeters squared. And we're going to go with 2 sig figs because 5.2 is 2 sig figs. Yeah. I guess, you know, I might have gone with 5.20, but when you cut diameter in half, it's really 5.2. Yeah. It doesn't get more accurate just because I divided. Yeah, it was the 10th place for centimeters. So those are some rules we'll go over again with sig figs. So now we have area times height. It looks like I left my units out, but I'm going to put them back in. Sometimes I try to skip steps, but then I just go back and I just can't help it. I've got to do things more the right way. But it helps to illustrate what the units for volume are. We have an area, which is, what was the area? The area was 85. The area was 85 what? Centimeters squared. That's area units. Multiplied by that third dimension, which is the height, 28.5 centimeters. So you have centimeters squared, and then you have centimeters one more time. So ultimately you get, there you go, right? 2,400 centimeters cubed. Okay, so this is great. I mean, this is the volume of our cylinder, but ultimately, if we report that as our final answer, that's not correct because we're reporting a volume in centimeters cubed. Okay, and our problem, there it is up in red at the top, it's always our target. Our target is find the mass in kilograms. But we can use a density equation. Now there's a nice little symbol for density. Um, Density is like this, it's the Greek letter rho. I don't know, maybe you're familiar, maybe you haven't seen it in a while. But the Greek letter rho looks like a curvy P, which is what we're drawing there. And P, or rho, is equal to m over v, where m is mass and v is volume. So density equals mass over volume, okay? And so I'm making it a point. My density of my H2O is symbolized by the letter rho, or, curvy P. And that's going to be equal to mass over volume. And that density, I know what that is 1 gram per every centimeters cubed. So that's what I can say. Rho is equal to 1 gram over centimeters cubed. But it's also equal to a ratio of any mass over any volume in which water is contained. Okay, so if we have 2,400 centimeters cubed of volume, we can figure out, hey, this mass m, we're solving for m, right? M is what we're solving for. And I know that because I paid attention to my question or problem. Okay, but that mass, we're going to divide it by volume, and the volume is 2,400 centimeters cubed. Now, if you look at all the units in my equation here, you do a kind of a cross multiplication, right? But you can kind of see that we could solve for, it's basically we're going to have like the number 1 gram is equal to m over 2,400. So then you just move the 2,400 up to the other side. Multiply both sides by 2,400. You can see the math, hopefully. But you guys should know your math, right? This is about just outlining the problem-solving steps. So what we see here is that we have a mass of, right, since it's 1 centimeters cubed and we have 2,400 of those, then we have 2,400 grams inside of that cylinder. 2,400 grams of water. So it's good. Like, we're showing our solution here. We listed our equations. We used all of our principles, right? Steps 3, 4, and 5. We should double check our units. We have been working with our units, right? Centimeters squared and grams. But ultimately, hey, look, kilograms. I'm underlining it. Our solution needs to be in kilograms. Okay, that's what the target said. If you don't pay attention to the question or problem at the beginning, you could not give the ultimate correct answer after you did all your work, right? And you have to check your units, and you have to check what the target was, which was for mass in kilograms. So we have more work to do at the end, okay? So we have to take our mass of 2,400 grams, divided by 1,000 grams. We have dimensional analysis again, and we're going to convert that into kilograms. Grams goes on the bottom because grams is what we're changing. We're getting rid of grams and turning it into kilograms. So our final answer will still be 2 sig figs, and it will not be 2,400, but it will be 2.4. And I guess I'm being fussy and I'm going to get text-based. Okay. So our final answer is 2.4 kilograms, the mass of the water that fits in this cylinder. And I'm just making it look nice here. for everybody to look at. And I'm probably going to change the size of, yeah. But it's good to have things presentable, gang. Fortunately, you'll be doing this pen and paper and take a picture or scan it to a PDF. You won't have to fuss around with all these digital tools. Um, but for the sake of creating these YouTube videos, it just looks a lot better when I use like a screencast. So the final answer is 2.4 kilograms. You should always box your answer. So my final answer here, I'm going to put a nice big square around it to accentuate the fact that this is my final answer. This is what I want you to see, all this work on the paper. So that's a reasonable answer because it's a pretty good volume, guys. Problem solving steps. So we've got a big 2.4 kilograms and a big volume. And also, guys, that 1 gram over centimeters cubed, that it's 1 sig fig, but it's a conversion factor, so it won't affect the sig figs of the final answer. Don't worry about conversion factors, sig figs.